Okay. To those who are not able to come or who weren't here at the beginning, I forgot to start recording. We just started explaining some things. I will uh, make it up in office hours sometime. And yeah, I guess that's what we're going to do. So, but we're going to go back into it. So back doing this. Let's see. Sorry, making sure nothing's breaking. Yeah, so when I reference mean, it's then what R is doing is pointing to other code that actually does the like hand computation of what the mean of a given set of numbers is, right? So um, it's the sum of all of the numbers in the set that we're taking the mean of divided by how many numbers there are, right? And while that's a simple computation for 2 and 5, like I could do 2 plus 5 and then divide it by 2, right? If we were looking at, say, 1,192 observations of one variable and we wanted to take the mean, it's probably a lot easier to have the computer do it for us. And that's something that highlights kind of why R is such a strong tool for us to do analysis and do stats and do stuff like that. Yeah. So does it make sense to everyone? Kind of. So it's like I'm typing mean, but really what it's doing behind the scenes is pointing to other code that has been written by the open source people doing it for free, bless their souls, writing a bunch of hard code. What that's like a term that you use. It's a term for like the sort of hand computation, the sort of stuff I'm trying to avoid having to do by just typing mean. And there are thousands of packages with hundreds of thousands of commands that do a bunch of different stuff. Just about anything under the sun that you can think of, there's probably a package for it in R. And at this point, I would point out that it's really important that that you don't need to memorize these things. In fact, if you did, you would be a crazy person, and I would be wondering how you do it, and I would be asking you for your secrets on how you memorize everything. So, and now, oh wait. No, this is a better. I'll use this as another learning opportunity. So for mean, if I don't know what mean is, let's say I don't know what it is, I can go, but I know that it's a command that I can run, right? I can go question mark mean and just type the name of the command, and then RStudio is really slick. It pulls up what we call documentation, and so what the documentation is telling me the ins and outs of what I can put into the command, what the command does, some uses for the command, some examples, and so we have a description of what it does. That's really useful when you're just trying to get a general idea of what it does, what usage of it looks like, and then gets to something we call arguments. So arguments are what we put into the function. So when we put in mean, it takes an argument x, an R object. Currently, there are methods for numeric/logical vectors and date, time, and time interval objects. So this is telling me what kind of objects that the mean function can perform whatever the mean function does on, right? So we have the x, which is, by the looks of it, numeric, logical, and I'll explain what some of these terms mean later. But numeric is pretty easy to understand what's going on there. Like we're plugging in some numbers, right? And so that's a type of x argument, what they call x, that you can put in to the mean function, among some other things. And then so there's trim, which I don't know what that means if I'm being honest with you, or na.rm, a logical value indicating whether na values should be stripped before computation proceeds. So in a lot of, especially in social science, we deal with a lot of missing data types. So let's say, for example, we're looking at economic data for African countries, and it's country year data. So we have all the countries of Africa for a set amount of years, right? Um, we're not always going to have information from every country for every year, right? If we did, that'd be awesome, and I would love that, and that would be a really useful data set. And if you have that, let me know. But that's not always the case. People are really stupid sometimes, and or they don't have the resources, and or they just don't report things. There's a lot of things that kind of go into why social scientists have to deal with NAs a lot in data. And it causes a lot of headaches when you're trying to do statistics because you have to account for those things. But so if let's say X, and so now I am reassigning, and I'll explain assigning more detailed. So now I'm going to reassign 2, 5, and NA. Let's say we have an NA value in there. And I'm going to take the mean of X, and I should get an error. Yeah, so it's going to come back as NA because the mean thing doesn't know how to reckon with there being an NA in the set that I'm giving it, right? But if I go back and then I add an argument or something that I'm putting into the function, and I delineate different arguments with commas, that's how I tell the given function that I'm using how, like, when one argument stops, or when one argument stops and when another begins. And Mason just asked a question. I'm going to answer it. Yeah, so NA, yeah, so that's a good question. So we have, and I'll again explain this later, we'll have a data type that are strings or characters. So that'll be like words. If I'm looking at qualitative data about how someone feels about something, it's survey data. There's going to be a lot of text there because it's easier for you to, send out a survey that says, how do you feel about this? I feel very strongly about this. I don't feel very strongly about this. I feel neither strong or not strong about it. There's going to be a lot of text involved with that. So the NA value is different. So yes, it is a different sort of data type. And it tells R, oh, we don't have an available, like it's null, like there's nothing there. You know what I mean? It points to nothing. So does that answer your question, Mason? Can I get a thumbs up? Yeah. Okay, cool. So back to arguments. So we've got an NA now in X. And when I tried to just do the mean of X, it broke and it said NA. Well, that's not true because there's 2 and 5 there, and I want to find the mean of those two numbers. So I can add an argument, which we again delineate by putting a comma there, and it'll autocorrect for you a lot of times, or you can hit tab and it'll give you suggestions. So I'm going to hit nar.rm, and so as it says here, it's a logical value. It takes a logical value, and that's a true or false, 1 or 0, right? So it's something where it's either true or it's false. So in this instance, I'm specifying whether, and it's set to false by default. Their default sort of, and that is outlined here. This is what sort of those things are. The trim, whatever that is by default set to 0. And na.rm, as we can see here, because it broke when we didn't specify na.rm, is automatically set to false, or by default set to false. Does that kind of make sense? The by default, like if I don't specify, it is going to by default assume false on that. That's kind of a weird concept. Does that kind of make sense to everyone? Kind of makes sense. It's okay if it doesn't, and please ask questions. Because if you have a question about this, I guarantee other people do. I was in your chair like a year ago, and it's really sort of intimidating sometimes because it seems like I know what I'm doing, but I do not. I promise. I only vaguely don't know, or I only vaguely know what I'm doing, and I would love to answer questions or clarify in a different way at any point. So we're going to set that to true. So we're going to type in all caps true. That's how we tell. And if it was something where it was by default true and we wanted to specify it to false, we would type in all caps false. Or for short, you could just put T or F. So we're going to set it to true. And then when we run that, it's going to remove the NA values and just look at the non-NA values, or the 2 and no 5 in this case. And again, it's pretty easy. I could just add up those numbers. Like I can see, oh, there's 1 NA. I'm just going to not include that. But when you're looking at thousands, sometimes tens of thousands of observations for a given variable that you're trying to perform some computation on. That's probably more complex than just taking a mean. It's way more scalable to use these tools than do all that work by hand. Yeah, we got a question. So you said the default for na.rm is false. Would you still have to put the f in there anyway? So no. So going back to when we first ran mean without specifying the na.rm parameter or argument, it's by default false, so it's not going to remove the NAs, right? And so then when I run that, the computer doesn't know how to parse it, and it's like, NA value, scary, So by default, it's false. So no, I wouldn't have to. So that is the same as me going in. I mean, I can specify it if I really want to, but it's just going to do the same thing, right? Because it's false by default. So if I specify it being false, I'm just saying, hey, I want you to do the default, but it's not necessary to do that. Does that kind of make sense? Sweet. Where to go next? I kind of have a sheet that I'm using to sort of reference so I don't get off track. Yeah, so let's do some math. We love math, right? I love math. So good. So yeah, you can do simple, addition. 3 plus 3 is 6, and that's going to spit back something. You don't have to put equals or anything. You just put that in. So and it's star for the multiplication sign. And I'm putting spaces. So in this here, I put spaces, but it doesn't matter if you put those spaces. It's going to read it the same. Spaces just make it easier to read, especially when you're doing a bunch of stuff and it's a big, long script, right? Easier to read that way. Some people don't do spaces at all because they don't care. That's kind of an aesthetic choice. You get that aesthetic choice. So yeah, we can do multiplication. So 4 times 2 is 8, right? So the asterisk is the multiplication sign. We can do division, 4 divided by 2. And like I said, the spaces don't matter, so I cannot put a space there, whatever I want. And then, believe it or not, you can do subtraction as well. Yeah, and so, yeah, let's talk about assignments now, because we can do arithmetic on objects. Like, remember, if we recall, I talked about objects. You can assign a name. So I have this thing, data, right? But it's not like, by itself, it's not going to be called data, or it's not going to be called data broader cat. You know what I mean? So I had to go in and assign that object or those values to an object. So, and I did that up when I assigned X. So let's reassign X. And we do that with this arrow operator. And again, the spaces don't matter. R isn't one of those languages that's really hard that reads blank space. Those are crazy. So the spaces don't matter. I just think it makes it easier to read. So we can assign X a value of 1, right? So then we see it then pops into our, I think I saw that we had a question. Caps matter though, right? Yeah, so function names like mean, yeah, so it's only going to work, yeah, if it's, yes, so to answer your question, yes, caps matter. Yeah, so yeah, it couldn't find function mean because capital M, yeah. So yes, capitalization matters. When you're writing text in quotes, and we'll get to that later, it doesn't matter because it's whatever you're formatting it or whatever the text you see in the data is. But when you're calling functions, yes, capitalization matters. And there will be some that are capitalized, like because there are so many packages and some of them are more used than others, when I'm making a new package, I might say use the same function name, but just capitalize it to delineate it if you're using both of the packages, and they might do different things, which isn't confusing at all. I'm just kidding. It is confusing, and I hate it when people do that, but it happens. So it's something to be aware of. So yes, that's a good thing to point out. Thank you, Mason. Yeah, so go back to this line. So as I did X, so X is the name of the object, right? So with this arrow thing, it points to the thing I'm assigning on the right side to, right? So like I'm assigning 1 to X. And then so when I hit enter, and I already did that, it shows up here in the top right in my global environment. I now have object X, and it points to the value 1, right? That's kind of a big thing. Does everybody get that? It's fairly straightforward, but I just want to make sure people get that. And you can't do it the opposite way. I thought I could for the longest time. You can't do this. Oh, frick. Oh, never mind, you can. Oh, that sucks. Okay, well, shows how... Wait, can you actually? Oh, shit. Okay, never mind. I'm an idiot. My bad. You can do it opposite, but it's best practice just to do it to the left. Man, that's embarrassing. And so as I pointed out, like here, so and when I was first assigning X a value, I used that C, and that stands for concatenate, or like bring together, or like, you know, smush together into one thing. That is the Webster's Dictionary definition for concatenate, by the way. I pulled that straight from them. So I can, and much like arguments, elements within the concatenated thing that I'm now assigning to X, I delineate separate values with the comma. And the spaces don't matter here, so I could do 1, 2, 3, and that's the same as if I space it out or whatever. You know, it's going to be 1, 2, 3. So now X is pointing to something, and this is another big thing to learn, to know. Please know this. This is now pointing to what we call a vector, or a string of values, right? And the values have a type, and it's delineated NUM, number. So what this is saying is X, the object X, is pointing to a vector of numbers of length 1 to 3, so of length 3, and then it lists out a couple of them, right? It does. If I have a million, it's not going to list them all out here. Like, that's not feasible. It'll list out the first couple. And I can do, if I wanted to, let me think of an example on the fly. Oh, yeah. So the best rooms in Wilson. The best rooms on Matterson. So concatenate, I want them, no, that's a bad example. No, that's a bad example. Let's say I want to save an object of countries. I spelled that right, yeah. So concatenate, and then I'm going to delineate words. If I want a value to be represented like by a word or a string, is what we call it in like computer science language, called a string, or character type, of like a character data type. We put quotes, so we put quotes, and I say countries. What's a country? United States, right? And I can put spaces there, and there it does matter, because if I save that and then I point to countries, it's going to say United States. Whereas if I don't put a space, I mean, I guess it gets the same message across, but if you want it to look nice, you know. So now, and we can do multiple elements that are strings. So we'll do Senegal, and we'll do bot swan. Oh wait, and you got to put quotes. I do that all the time, and then R yells at me when I forget to put quotes if I'm doing a bunch of things like this. So bot swan. Yeah. So now we have. The object countries is pointing to a character vector of length 1 to 3, and it contains, and it'll name off the first couple. I actually forget what it does if you have multiple types. Yeah, I think it does just like whatever's in the majority then. One sec. Oh, okay, that's interesting. Oh, yeah. Oh, that makes sense. Okay. So if you add a character type thing, like something in quotes, it's gonna coerce the rest of the objects in, or the rest of the elements in a vector to that type. But that's not super important. You'll rarely have mixed variable types within one vector. The important thing is to know what a vector is. It's a string of values. So oftentimes we think of data frames or like tables or like a like what we had here. We have different variable names on top. So we think of each column as a vector, right? So what this is just a two-dimensional vector, right? Does that make sense? Make sense? Yeah. So we did, so assignment. So let's sort of review. We did some math up here. We can do simple math. And we can also do math, I guess, so we can also do math with objects, right? So I wonder what this does. Yeah. So I'm gonna make that look nicer. So I have x. X is a vector containing 1, 2, and 3. Let's say for whatever reason I want to add 2 to each element of the vector, right? I can go x plus 2, and then that returns a vector with 1 plus 2 or 3, 2 plus 2 or 4, and 3 plus 2 or 5, right? So I can do stuff like that. And then let's say I want to multiply it by 2. So let's go x times 2. So now I'm getting 1 times 2, which is 2, you see where this is going, right? But so I did x plus 2 here and it gave me that, but then I did x times 2 and it referred to the original one. Well, that's because I didn't change what x, the object name x was pointing to, because I'm not reassigning it. Let's say I wanted to reassign x as x plus 2. I can go do the point thing again, x. And now when I do x times 2, and we can see it update in our global environment in the top right. Now x is pointing to 3, 4, 5. And when we do x times 2, it's going to do, it's multiplying these numbers, the one that x is assigned to, right? The vector that x is assigned to. So now it's going to do 6, 8, 10, right? Does that make sense? Kind of the difference between just performing a computation once and then assigning it. So it's like almost like saving your change if you wanted to save it. And that's also helpful if I just wanted to look at what the data looked like. If I say did a log transformation, which is something we do in regression sometimes. So if I wanted to log all the numbers just to see what it looks like, I could do that in the console without saving it, right? Because the danger in resaving it and overwriting the same variable name or the same object name is I accidentally overwrite it and then I lose the stuff I had before and I don't have it anywhere else and then I lose it, which would be tragic. Does that kind of make sense? So if I wanted to, let's go back and to go back, by the way, this is something I just don't even really think about. I'm going up and down on the arrows on my, like the 4 arrow keys on your keyboard. If you go up, and maybe it would have been smart to have you do this along with me or something. I don't know if anybody's been doing that, but if you feel ever so inclined, I can't really see what you're doing. So to do this stuff along with me, it would be good practice. You're like, I can code. I can do the code thing. If we go back, yeah, so I'm pressing the up key to go back to what I was typing before in the console. That's a useful thing. So we go back to x is 1, 2, 3. Let's say these numbers are meaningful to us in some way. Maybe they represent, I don't know what they would represent, but they represent something. So let's say I want a new variable, or I want to save x as the multiplied by 2 version of x, but I also want to save x as 1, 2, 3, because let's say there are way more numbers and I can't just reassign it, So I'm gonna make it, it's really common for you to make a new variable with a similar name, right? So we'll call it x doubled, right? That's meaningful to us, right? And it's really important that we think about variable names and object names as something that would be meaningful to a certain extent. Like you're not going to type out you're not going to do it's X but doubled, right? You're not going to type all that out. But like if you just put a simple X doubled, and that's something that you sort of pick up as you go along with it. Like I'm still bad at variable names sometimes. Like I'll make a really dumb over, like too ambitious of a variable name, and it's confusing to look at and it makes it look messy. But you know, we're all learning. So I'm going to take X, and because I said I'm doubling it, I'm going to do 2 times X. And so now I have another object which has, so now I have X, I still have X, right? And because I made a new variable, this new X doubled variable now points to the doubled version of X, right? So I'm able to keep both. And that's really common to do. That's a common thing. So like if I'm doing analysis and I want to save the original raw data, but I also want to transform the data, I would maybe have data, and then I would also have, I mean, yeah, you can kind of see, I don't remember what the transformation is between data and data broader cat, but broader category, but I don't know what the broader category would be. It's irrelevant. The point is I have both of them, and you can see they have similar dimensions. They have 1,192 observations, so lines, right? Like observation 1, observation 2, right? And then 150 variables on the top, so 150 columns. So they have the same dimensions. There's some difference between them. What the difference is, I don't know, but like presumably I would know if this was something that was more meaningful to me. So say this is data, and I had data log transformation, like I was saying before. I logged a particular variable or particular variables that need to be logged for the analysis I'm doing. I would save that to a different object. That way I still have the raw data, so people can replicate things, or people can look at my raw data, or maybe the raw data will come up later when I find out, oh, well, maybe I want to do a different transformation. Then I have both. So that's a really important thing to know to do. Yeah. Are there any questions at this moment? I kind of been talking a lot. Yeah. Okay, cool. So what else? I did vectors. Oh yeah, we can talk about the in operator. Yeah, so I referenced logical operators before. So true, false, 1 or 0. And that's really important if like we have some criteria. Say I, you know, how am I? Sorry. Can you cover how to load a data sets? Yes, I will be covering that. I can do that after I talk about this in operator, because we do logical operators and then we can close out the last 15 minutes. Man, time flies when you're having fun. I can cover sort of loading data sets after that. So y'all know from probably middle school math, the greater than sign, the less than sign, equal sign, right? So I can go 3 greater than 1, and it's going to return true, right? Because 3 is greater than 1, right? So true, it's going to say true. I can do 3 is less than 1, and it's going to return false, false. I can also do greater than or equal to, right? And you put the greater than or less than sign first and then the equal to. So it's like greater than or equal to. And that's true, but it would also be true if I put 3, right? And then similarly, I can do less than or equal to. Oh, wait, no, I just put 3 again. Why did I put 3 again? Oh, why did I put 6? That doesn't make any sense. Okay. Yeah, so there it's false because it's, yeah. And then so making those comparisons can be helpful when you're looking at data and you want to compare like between countries, like let's look at GDP or something. And I can go through, and so yeah, you can do that with strings too. So we have, remember, let's go back, we have X and X doubled. So we'll go X doubled greater than X, which is true for each element, right? Right. So it's true for each element. Let's make a new one. So we're gonna make Y, and it's going to be concatenated, right? Because we're going to do 3 elements just so the dimensions are the same. And we're going to do 0, 7, and 2. Yeah, so that's y. Okay, so now we'll do x greater than y. And so x is greater than y at the first element and the third element, but not the second element, and it gives me that vector accordingly. Yeah. Trying to think what else would be. Oh yeah. So there's like the in thing. Let's see. I'm just gonna copy this. To be fair, I made it, so I'm not really copying anyone. So, yeah. So 8 is, so this in operator. It's similar to the greater than or less than thing. Think of it in the same way, except it's you put percentage sign. What's the percentage sign? In percentage sign, and that's what that does. So if we did 1 in, oh wait, no, not 1, but I'll change that in a second. So I'm gonna copy and paste that. So if we did, so this would be like I'm asking, is 4 in this set? Is the number 4 in this set, right? So I hit enter, and it's true, right? Because 4 is in the set. Yeah. Any questions about those logical operators? You don't use those a ton, but again, we're just kind of going over syntax just so we can be comfortable with syntax. Okay. Yeah. So let's talk about reading data sets. So there's a function in base R called read.csv. CSV is very often the type of, actually, no. Let's backtrack. So we talked about this bottom right pane, and the packages are here, and you see what packages. So I have the, these packages are in, and they're check marked, and I can say I need to use something in the foreign package. I hit check, and then it, and I can also go in and go library. You see gdata on there, and I can load that in, right? And then it check marks it there. If I don't have a package, so y'all have presumably just downloaded R and you don't have all these packages because you haven't been doing this stuff for a long time or really any time at all. So a really important one is install.packages, which is another util function. And if you look up the name, so one that everyone is going to need to do, and in fact, let's do it all together here, is the tidyverse. It's the most important package. It's this really nicely developed thing. It's a political science, and everyone kind of uses it a ton. Standard package with a standard set of functions that are really useful, really easy to use, really versatile. And that's kind of what we're going to be learning in this class, because it's what real life political scientists use. When I took this class last spring, 301, we used this crappy Pollock book that had all of its own functions that no one actually used in real life, which you can see being not very useful because it's like, I mean, like a lot of math you don't actually use in real life, and you're like, wow, I'm never going to do this in real life. What's the point of learning this, right? But this was like, I'm learning a tool. It's like learning how to use like a special type of screwdriver that no one ever actually uses. It's just to teach you how to learn how to use a screwdriver, I guess, is a metaphor I can use. So yeah, so we're going to be using the tidyverse. So install.packages with the parentheses open, which is, I didn't explain it, but you may have picked up that's kind of what you do with functions. That's how you put arguments into functions. And so when you're downloading a new package, you have to put it in quotes because it's gonna, what R does, what this function does is it scours the internet for it. And so we're gonna type in the tidyverse and then hit enter. And then it's gonna do a download. And it's gonna re-download it. It doesn't take very long, yeah. And then, so if I hadn't done that and I did library tidyverse, it would have been like, I don't know what this is. I don't know where this is. I don't know what you're talking about. But you have to install it, and then you can do library tidyverse, and it should autocorrect. Yeah. that makes sense to everyone, kind of how we download packages like that, and what packages are. Does anybody have any questions about like what conceptually packages are? Okay, cool. Yeah, and so again, in this bottom right pane, plots will go here if we plotted some data. I'll just show what that looks like. Data. I wish I had a better data set that I knew better to use examples for. No, that's not good. Don't worry about how I'm doing this. I'm just trying to show you what a plot looks like when it shows up. Okay, I'm doing a poor job at that. What's a numeric variable? No, I don't like this. How about I import a better data set and then I can show you on that, yeah? And we can show you how to do that. So one of the more useful ones, and I understand if y'all don't pay attention to file structure all the time because you're not computer science nerds, which is understandable. So you can sort of access your files like you do, if you have a Mac like you do in Finder, right? You can kind of traverse stuff here, right? So you can do a similar thing within the RStudio. It makes it the sort of transition really seamless and everything. So let's go into COVID analysis. This is something I was looking at, something I was doing. So we have a CSV file here. So I'm going to click on this, and then I'm going to click Import Data Set. Right, so this is the code preview. This is what it's doing. It gives me a little preview of what the data set looks like here. This is one I merged together earlier this summer. So this is what, you could do this manually, of course, if you wanted to. But for y'all's purposes, I think it's mostly useful if you just like download whatever you're looking for. And I don't know, I think y'all are all on the canvas. I can't see who's on the canvas, which is really cool. But all the data and all the CSV files up here that you'll be using, I've put all of them in. And if you encounter where I'm like, I don't know where this is, I probably just forgot to put it in, and I'll put it in, or I'll email it to you or whatever. So all the data that you should need for the class, and I'll add anything as because I had you fill out that survey asking, what you're interested in, what kind of topics in political science are you interested in, or in politics generally. And I can go find some data sets and make some new exercises based on that data, just so it's a little bit more familiar for you. So you click on it. It gives you a little code preview of what it's going to run when I hit import. It's going to name it, and you can change the name. I'm just going to keep the name as is, but you can change the name if you really wanted to, or you can change it once you get it imported. This shows the file path, but we're not really going to worry about that right now. I mean, if you are so inclined, you can look into file path stuff. That's sort of what I've been sort of getting familiar with this last summer, or I sort of got familiar with it this summer. So but we're going to hit import, right? So then it imports the data, and because it said it was going to view it, so it's now COVID fears v2 CSV is now up here. It gives us the dimensions like before, 26 variables with 185,480 observations. And I can view it up here in this pane. This is a data frame. Yeah, so that's like the best way is sort of traverse. So let's say I want to download. There's something Dr. Urbach just emailed me, some data sets. So we can download that, and I can show you kind of the whole process. So the Morning Consult governor rankings. So let's see. So oftentimes, like, there's no one size fits all answer to finding this data, and it looks like I have to request it. So this is jank. Not something I can do right now. So I'm just going to re-download something from the Canvas, just in general. Yeah, so so when we get into working with scripts rather than just in the console, it's important to say, so like say with this, this untitled 2, hello everybody. Actually, no, the cliche coding thing is hello world, so we're going to do that. So I've made changes to this now, and I will want to save these files. These are like individual files, and I can choose where to save them right in my sort of whatever, you know. So with files like that, yes, it's really important that you save it. When you quit out, it will save this environment by default. Like just when you quit out, it'll do that for you. If it ever asks you to save something, probably save it, type thing, like as a best practice. But I don't. I think it saves the global environment and the stuff you've imported in automatically. I'm running out of time. Stephen, does that sort of answer your question about importing data sets? Or if anybody else has questions about data sets, well, I'll kind of review that next time when we go over sort of introductory manipulating data frames with tidyverse stuff. This was just kind of to get our syntax down, and there will be a group work sort of thing if you'll look in the assignments, and that'll be due on Friday. It's pretty easy. I'll look over it, and yeah, so this is kind of the wrap up now, I guess. So please email me any and all questions. No question is too small or too insignificant. It's really important, especially at this foundational part, that you sort of ask the questions you need to ask, because yeah, getting a really good foundation is really important, because I was self-taught. I didn't like have some dork teaching me how to do all this stuff, because I was like, I'm just going to try and figure it out by myself. And that was a bad call for a lot of reasons, because a lot of the sort of foundation was flawed because I interpreted things weirdly or it wasn't right. So it took me a while to sort of get off and running with this. But I'm gonna stop sharing my screen. Yeah, so thank you all for coming to this first thing, lab thing, class thing, I guess. I will look over the poll results and tailor the next things accordingly. Looking at the group work now just to make sure. Oh, I think I forgot to put that data set in. So I'll put that data set in, or I might just change it or something. Wait. Oh, I think that's something. Yeah. So if you just run that line, I don't know if you're looking at the group work, but there's a line that talks about EU stock markets. I think that's something where if you just run it, it's something that's saved sort of in R. It's like a historical data set. Yeah. There's some things that are just like saved in R that sort of, it's like a thing that I don't know why, but it doesn't really need to make sense, because you're just going to run that line and it's going to give you a bunch of numbers that you do some of these transformations that we were talking about in class, or whatever this is. I have a hard time calling it a class because I'm an undergrad, so I think it's a lot more informal than that. So but yeah, so thank you for coming. Again, email me if you have any questions, please. I am always looking at my email. Almost too much I look at my email. So I'll probably see your question and I'll try and answer it as quickly as I can, probably within 2 hours, unless it's like 11 o'clock, because then I'll probably be asleep. But yeah, so does anyone have any questions about kind of how that goes? If you could just do, the group work shouldn't take you more than 30 minutes, if that. Maybe you'll want to play around with stuff, or maybe if stuff doesn't make sense, it'll maybe take a little longer, but it shouldn't be very much of a problem. And I think this course is just pass fail, or the like lab thing, it's just pass fail anyway, so I wouldn't really worry about getting grades. I don't even grade it technically. I think Dave is, or Dr. Peterson is doing it. So yeah, it's low key. It's all about the code. So does anyone have any questions about anything? Everyone in the Canvas?
How do you want us to submit the assignment?
Yeah, so that's a good question. Then it would have been cool if I had gone over scripts in this class because that would be a really easy way to assign it. I will make a video. I've got a class at 2:10, so I will make a video about scripts and how to save them and what to do with them and kind of how they work after class today. And maybe I'll make the homework or whatever due on Monday, right? It doesn't really matter or anything. So, or it's not really homework either. It's like a group work type thing. So it's like less formal, and so it's more of like a reinvigoration of the stuff we already went through. But I'm going over time, so yeah. So I'll make a video explaining kind of what scripts are and what they do because that's something I maybe should have touched on. But I feel like it was also important to go over the other stuff today. So yeah, I'll make a video and I'll send that out via email. I need to make a listserv. So yeah, that to answer your question, that'll be how because you'll. Within those scripts, and that's something that makes RStudio really nice, is you can save a bunch of code into one place, into one file, and it'll be a .r file. So like you know like .pdf or .excel or .csv files. It'll be a .r file, and it'll just show up as like a text file, and I can run that on my computer really easily. I can just copy and paste it, so or just import it in. So yeah, that shouldn't be too difficult to explain. I'll make a quick video. Later this afternoon. So, but yeah, I don't want to keep y'all and I want to go to class too. So thank you so much for coming. Thank you so much for being interested in being taught R. It's really cool. I promise. Really powerful tool. And yeah, so I hope y'all have a great day. Yeah, go Cyclones, I guess. Bye everyone.
Thanks, Zach.
Cyclones.
Thank you.